Good morning, my name is Mathew Taylor. I am the CEO of Shift Computer Solutions, and today I want to talk to you about exploding computers and how best to avoid them. Arthur C. Clarke said, "Any significantly advanced technology is indistinguishable from magic." And while I'm going to show you some advanced technology today, and while smoke is sometimes a part of this story, it's not magic. It's just a result of some really brilliant engineers doing some smart work to protect us, in some cases, from ourselves. So what is the problem that we're going to talk about today? The problem is disruptions of the electricity supply to your expensive computer and other equipment. On the computer side, power interruptions can cause lockups, cause your computer to reboot, and in more drastic cases can kill the computer completely, potentially damaging your livelihood. So storms and weather events are one such way that most of us know that power problems can occur. And certainly if you see a storm coming, you have the option to unplug everything and run around your office and shut everything down. But two big problems there, of course. One, are you always there when the storm is coming? And two, can you afford to close your business while the storm passes? Most of us can't. Accidents, believe it or not, can mess up the power supply in your office and your business. We have actually had a case where a client was working around their computer and a car crashed into the power pole outside their office. This slide is not that car, but it is reminiscent of that. The individual's computer literally caught fire because of the power disruption that went into the building after the pole was hit. Your neighbours can be a big source of problems for your business and your computer equipment, particularly in industrial areas where you've got welders and other high current equipment. That affects the power grid in the local area. And so if your neighbours are doing something a little bit excessive, you can have problems with your equipment and not realise what's going on. So even the equipment in your office can create problems for the equipment in your office. Not all equipment is made equal, and not all of it behaves itself. And quite often a dodgy bit of equipment can actually send nasties back through the local circuit and blow up other equipment and cause problems and lockups and things. So all of these disruptions cost you time and money and repairs and replacement costs, but most importantly, they cost you money when your team aren't working because their computers and other equipment aren't working. And even more important than that, what if your major computers die and they take all of your business data with it? Obviously I've done a talk about that in the past. But the cost to your business can be significant, all from a little bit of nasty voltage coming into your computers. So the question is, what can we do so that these things don't happen to us? Well, I'm guessing most people watching this talk right now are thinking to themselves, well, duh, I'm going to get a surge buster board and everything's going to be sweet. So just like this one, I've got my demonstration computer here. I've got it protected with a surge buster board, so we're all good, right? That didn't sound too good. So, what went wrong and killed my laptop? Well, I've used a surge board. Surely I should have been sweet, but I wasn't. When it comes to electricity, there are four ways that it gets you. The first is voltage. We've all heard about voltage. The electricity supply in Australia is supposed to be 240 volts, and so our equipment is designed to take 240 volts, and if it gets lots more volts, guess what happens? Smoke comes out. Amps is the power of the electricity supply coming into your machine. Circuits in Australia are typically 10 amps, and if you get a lot more amps, the equipment is not going to be able to cope with that because the wiring is designed to pass less than 10 amps. Most of your computers and equipment are an amp or two, they're nowhere near 10. Then you've got total energy. Energy is just a measure of the amount of literally energy that's coming through the circuits and so forth. And in the case of surge protection, you have to absorb that energy and not have it go through to the computers. And so the ability to handle a certain amount of energy is important. And lastly, and I think most importantly, response time. The electricity supply happens pretty quickly, and so if you're going to have a surge protection device, it needs to respond very, very quickly if something happens, so that it protects your equipment. So I thought we'd have a quick look at 4 products which I have looked up and are available everywhere, and I've called them product A, B, C and D for what should be obvious reasons. And if we look at the specifications on these products, you can see that Product D has the lowest clamping voltage, that is the voltage at which it will cut in and protect your equipment. Now, 680 sounds to me like it's a bit high. We're only supposed to be getting 240 volts, but it's the lowest of all of them, so I'm guessing that must be really good. I had a look at product C. It's pretty poor, worst clamping voltage. You can see it only handles 4,500 amps, whereas product D handles 60,000 amps, so it sounds like product D is pretty boss to me. And then I looked at product A. Not quite so good on the volts, not quite so good on the amps, but if you look at the energy absorption, it can handle twice the energy absorption of the best other product. And in fact, if you look at product C, it's a bit of a joke in terms of how much it can absorb. So looking at that, response time, product C is also a bit of a joke, and the rest of them are all at 5 nanoseconds. So I'm guessing 5 nanoseconds must be pretty sweet. So I'm guessing, if all of you are looking at the same slide I'm looking at, that you're all going to put your hand up to buy product A. Would that be right? That would be wrong. But let me tell you why that is wrong. What you should in fact buy is a Thor D1 smart filter. Well, not that Thor, although I think you do more damage than actually protect your equipment. What you want is that Thor. And if you have a look at the specifications of product A compared with the Thor D1 smart filter, you can see that the Thor smart filter clamps at 275 volts, which is very close to the 240. And you might say, why doesn't it clamp at 240? Well, the answer to that question is, if it did, it would be cutting the power off to your equipment all the time, because it needs to have some leeway for the fluctuations in the voltages. You can see that it handles a whopping 156,000 amps, more than twice what product A can handle. It can absorb nearly 5,000 joules of energy, triple what product A can handle. And I think most importantly of all, it responds to problems in less than 1 nanosecond, which is 5+ times as fast as our looking good product A can handle. So clearly, Thor have a product there that is streets ahead of whatever else. And if you're running something else under the desk, you are likely risking all of these sorts of problems. I thought we'd have a quick look at the insides of these units. I was certainly thinking, well, you know, what's inside the guts of these devices? And I thought we'd compare a competitor's product to a Thor board. And if you have a look at the competitor's product, that is the circuitry protecting your computer in the one particular product that I decided to pull to bits. It has a metal oxide varistor, that's the blue thing there. It has a capacitor, which is the yellow thing there. It has a resistor, which you might not be able to see because it's very tiny. And it has something I almost guarantee you can't see, which is a tiny fuse wire designed to burn out in the event of drastic failure. Not a proper fuse, literally just a piece of wire. If we look at the Thor D1, actually before we look at the Thor D1, the other thing that bothered me is how this machine was wired up. Basically, if the surge protection circuit in this board fails, it simply passes the mains power to your computer, which we'll come back to in a minute, because that's really bad. If you've got no surge protection at all, you want to know about it. Looking at the Thor board, this is the actual circuitry from inside a Thor D1 smart filter. The photo cannot do it justice because it is cram-packed so full of circuitry and components protecting your equipment. It's light years in front of the competition. And you can notice, you might not be able to tell, but there are in fact 8 metal oxide varistors in that photo protecting your equipment. The other end of a Thor board also protects your Ethernet ports on your computers, and what people don't realise is that phones and network connections are a common way that your computers get killed. In fact, we have a customer in Willawong who had a storm came through, and they had 8 computers broken after that storm, and they were all killed through the Ethernet port of the computer, not the power supply of the computer. And unlike most competitors' boards, Thor actually have protection on that as well. So the normal practice is just to earth those connections, but of course the earth wire is connected to the power supply, which in many cases has bad surge protection, and so you're just creating a feedback loop of disaster waiting to happen. So the Thor actually has some metal oxide varistors there and some other componentry to protect that circuitry as well. So a quick word about metal oxide varistors, which is just a word I like saying. We'll call them MOVs for now. This is a photo of an MOV being hit with too much current, and I don't know if you can tell, but it's catching fire. And this is what happens with MOVs. They dissipate the extra current into heat. It's got to go somewhere, and so our MOV simply turns the excess energy into heat, which is a great way to get rid of it, unless there's a lot of it, in which case the MOV will get hotter and hotter and hotter and catch fire and burn your office down, which is fantastic. So you really don't want a product that does that. And if you look at the Thor boards, they actually have a thermal fuse as well as all the other doohickeys. I've circled it there, I'm not sure if you can see, but it's a tiny little metal fuse thingy inside the MOVs. If it gets hot, it cuts the power to the entire board and your office doesn't burn down. And I've also discovered that the plastic that the Thor board is made of is fire resistant, it won't burn. So even if it did try to burn, it won't. So your office can burn down, the Thor board will still be there, protecting your computer. Fantastic. So the last thing I want to quickly say about the Thor product is that they also protect the earth line. So probably not too many people are electricians, but electricity is active, neutral and earth. That's why you have 3 plugs on your power cords. And most boards don't protect the earth, and the earth is where probably half the problems actually come from. Both from the earth in the building, but also other products that you've plugged in around the office. Quite often the earth is where the nasties from them goes, and if the board isn't protecting your earth line, then they go straight into your computer. So Thor Technologies have a range of products. I've only talked about the Thor D1 today because that is the product we sell 99 times out of 100. That's the product you want under your desk, protecting your computers and your printers and all of your other gadgets. But they also make things that go in your circuit boards if you want to protect at the supply. They make things that go in your server racks. If you have a server rack at your office, you can protect that. They make the Thor Green board, which is a fantastic board to help you save some electricity. It allows you to easily turn the power on and off at your desk without crawling under it. And they also make power conditioner devices, which is the big box in that slide, for really important devices that need a lot of protection and need really, really clean power, more clean than you can get just from basic filtration at all. So it's like I've always said, if you're not protected by a Thor, you're not protected.